our goal on the second page is to understand how do we graph an exponential function. Now just reviewing again. The first number in the graph, that 0.5, okay, that's like your starting point. The second number is your multiplier. So here we have a pretty normal function. It's a power of 2, 2 to a power. So it's going to go up in that doubling idea. Now we need to plot enough points on our graph to get a feel for what this looks like. Now I put 4 spaces in here. We may need more, we may need less. So let's just try. What would be a good point to try to start with?
0.
All right, so let's try 0. I am going to draw a line kind of through the middle here because I'm going to anticipate we're going to use more than 4 points. So 0.5, you need your calculators here, 2 to the 0. Now remembering, this is reviewing for tomorrow. Anything to the 0 is 1. So 1 times 0.5 is 0.5. So let's graph 0.5. There we go. Another point we want to try. 1. 0.5 times 2 to the first is, crunch it on your calculator. If you don't have them out, start crunching. Doesn't have them. All right, what was it? How much? 1. 1. All right, graph it. Let's try another one. 4. 0.5 times 2 to the 4th. 2 to the 4th is 16. Half of 16 is 8. Because someone said 4. All right, now here's the deal, Jalon. I can't choose anything above 4 because where am I on my graph? I'm at the top, right? So we better choose
3.
Okay, let's try 3. We'll go negatives in just a sec. 2 to the 3rd. We should know 2 to the 3rd in our heads. 2 to the 3rd is 8. Half of 8 is 4. So 3, 1, 2, 3, 4. Did I count wrong?
Yeah, that's what.
Sorry, I was at 2. Do you see kind of a curve there? Kind of going up? Kind of looks like a parabola. Let's look at some negatives. Negative 1. 0.5 times 2 to the negative 1. All right, go ahead and plug that in. 0.5 times 2 raised to the power of negative 1. What do you get? 0.25, right? So go to negative 1 and go to a quarter. Don't touch that line, though. What do you want to try next?
Negative 4.
Negative 4. 0.5 times 2 to the negative 4. 0.5 times 2 raised to the negative 4. What do you get? Justin, where's your calculator? Use it, please. What do we get, guys? Really?
No.
Who's got?
0.03125.
0.03125. So I've got a graph. Is that going to touch this line? That's 2, 3, 4. But it's going to be really close. Do you think we're ever going to touch that line? Just for the sake of it, put in negative 8. See what you get. Plug in negative 8 right now. Let's see what we get. Who's got it? Go ahead, Abby, read it. 0.001. How much is that? 1/1000. How can you graph 1/1000? Effectively, you put a dot as close as you can to that line, But don't what? Put in negative 10. Put in negative 20, somebody. Put in negative 20. It's not humanly possible to write a dot that small. That's true. 0.5 times 2 raised to the, what did I say? 0, 0, 0, 0, 0, 6 zeros, and then 477. But still, it's not what? 0. Now, here's my question. Put in negative 50. And watch what your calculator does. Put in negative 50. What does that mean? Is it still at 0? It's times 4 to the negative 16. That's scientific notation, right? So it's still not saying it's 0. Is it getting close? It's getting really, really close. But do you think this line is ever going to cross that x-axis? It's never going to get under there. All right. So when you draw this, try to draw it in such a way that it kind of shows a little bit of air gap between you and the x-axis. And put your arrows on there. That's an exponential function. It decreases down and flattens out to kind of a bottom level, and then also on the other end, Sam, it just shoots up vertically, on the other side. Yes, sir.
Why is it going scientific notation?
Because they have no other way. Here it is on mine. They have no other way to express a number that's small. Now I could tell you to write this in standard notation. How many decimal places would you have to move this over? 16. I would have to have 16 zeros. And then there. Now old calculators that didn't have scientific notation would just default this to 0. But was it really 0? No. It's close. It's really close. But it's still not 0. All right? Let's look down here at a little different one. 0.1 times 3 to the power. All right? So by now you know you need to do a couple numbers on the positive side and a couple numbers on the negative, and we should probably also always do 0 itself. So let's try with 0. Someone else try 1. Someone else try 2. Someone else try 3. Okay? Someone try negative 1. Someone try negative 2. Someone try negative 3. All right, so pick one of those. Don't just do the top one. And let's work them out. 0.1 times 3 to the 0. 0.1 times 3 to the 1. 0.1 times 3 to the 2. 0.1 times 3 to the third. 0.1 times 3 to the negative 1. 3 to the negative 2. And 0.1 times 3 to the negative 3. All right, so give them to me. Who's got one of them? Grace, what do you got?
I have the 3.
Okay, what do you got?
It's 2.7.
2.7, okay? Somebody else, John.
I have
The
the 0.
0 is 0.1. Somebody else. Luke.
I got 2.
Okay?
And that's 0.9.
0.9. Pick one that hasn't been done yet, guys. Crunch it out. Tell me when you got it. Justin, work it out. Abby.
-3 is
0, 0,
3.7.
3.7. Okay? Drew?
1 is 0.3.
0.3. Somebody else. Jalon.
I got the -2.
Okay?
0.01.
All right. And what about negative 1? Does someone have that? Negative 1. Go ahead. 0.03. Repeating? All right, so let's graph this. 0.1. Wow, it's already where? That's .01's repeating?
Yes.
Okay. 1, comma, 0.3. 2, comma, 0.9. I'm still not above 1. But do you see a curve? Even right there, do you see a curve? Okay? 2, comma, 0.9. 3, comma, 2.7. Do you think we can squeak a 4 in this one? Let's try. Oh, you have it already? 8.1. So 4, 1, 2, 3, 4, 5, 6, 7, 8. So I'd say that's valid. 8.1. How fast did that turn and make that vertical? Is it just really now starting to take off? 5 is going to be up at 24. 6 will be up in the 70s, and it's flying in the vertical manner. Let's try the negatives. I don't know how I can graph these. I can't get that close. I guess I could do this. If there was a way that you could zoom in, what would these dots be doing? Getting closer and closer and closer. But realistically, how can I graph 0.0037? I can't graph 3/1000ths. So you're just going to have to draw that line as close as you can. But you don't want to make it look like it's touching. Sorry. All right. So you don't want to make it look like it's touching, but you still want to make it look like it's an exponential function. So you got to give enough points to give it framework. But don't give it so many points that, it's like that. Now look at the top graph, look at the bottom graph. How do they compare? Are they the same shape, basically? Okay, this is the basic shape of an exponential function. What's different about them? They're not what? Okay, they're not straight. Exponential functions are definitely curves. Good. What else is different as you compare the two graphs? What do you notice about this one? How fast is it going up in comparison to that one? Look at the turn here. Is this a sharper turn? Look at the turn there. It's more what? Gradual. Look at the multipliers. What's the multiplier on the top one? The multiplier here is 2. What's the multiplier there? A 3. The higher the multiplier, guess what you can make a prediction about your curve? The sharper the turn's going to be. Okay? Now tonight, they may give you an exponential function, Tara, where this multiplier is negative. I don't know if they do it or not.
Well, the answer.
Okay? So then it's going to maybe turn and flip down. Or they may give you one that's flipped this way. And so they may give you one that looks more like this. So be careful as you're plugging your stuff in tonight, Luke, that you're using parentheses anytime you see negatives. Always parentheses. Because otherwise, your calculator is not going to give you the right thing that you think it's supposed to give you. Does that make sense? So really, let's be careful if they give you a negative that we have parentheses. All right? Okay, tomorrow, quiz. Review your practice quiz again if that would be helpful. And then we have this short assignment here. I think I gave you graph paper, didn't I?
No.
Yeah, page 43, I have graph paper for you. So, there we go.